Arnav, Bhumika, add them and get the answer. Second one, Bhumika, have you solved that one? A and T. Now, Arnav, what we have to do to get acceleration value? You have to add equation number 1 plus equation number 2. So, if you are adding to the left side, what you will get?
Sir, A is m2g minus m1g sine theta divided by m2 plus m1.
Let me say, so m1 plus m2 common A will be equal to. Now here we are adding both. That means m2g minus t plus. So that means t will be cancelled, and what will be there here? m2g minus m1g sine theta. Now if I write a value here, let me write this side left down. A is equal to what I can take common there. G I can take common, no? So if I take G common, m2 minus m1 sine theta divided by m1 plus m2. Whether this equation is there for anyone, A is equal to m2 minus m1 sine theta into G by m1 plus m2. Whether this equation is there for any option?
The A and
A and C both are having same option. That means now B and C are wrong answers, no? Right, B and C are wrong answers. Now you have to choose from A and C. And now what you have to get? You have to get T value. And to get T value, what we have to do?
divide.
You have to divide equation number 1 with equation number 2. And divide and get the answer. Bhumika, you given answer A, but check once whether T will be equal to that value only or not. Now what is equation number 1? M2A. Okay, let me write here. What is the first equation? M2A. So M2A divided by M1A is equal to, what is the first equation? M2G minus T divided by, what is the second equation? T minus m1g sine theta. Now a will be gets cancelled, and now you do cross multiplication. And if you do cross multiplication, first m1 m2g minus m1t is equal to m2t minus m1 m2g sine theta. Now here what I am doing now is, so where I have to write? Okay, I'll write here. Okay, now here m1 m2g minus m2 m1g sine theta minus I can write, or plus. If it comes to this side, plus I can write, is equal to m1 plus m2 common t. Okay, now what you can do, t is equal to m1 m2g plus m1 m2g sine theta divided by m1 plus m2, isn't it? Now which is the right option there? M2g common they wrote, and if you take common m2g common, if you take m1 plus m2 sin theta by m1 plus m2. Now cross multiply and tell me, Arnav, whether you are doing it or not. Arnav and Bhumika, Sahas, whether you are doing it or not. Arnav, are you there? Arnav, once you speak.
Sir, A and C have both the same options. I mean, they are not different.
Why not different? 1 minus. Once you check there, 1 minus m2 minus m1 is there. Here m1 minus m2 is there.
M2,
For
okay.
sin theta is there for m2 in case of C, but sin theta is there with m1. Think there. Now here if m1 plus m2 comes for first option, what will be there? M2 will be cancelled. So m1 will remain m1 m2g minus into minus plus. Okay. Now which will be the right option? Sin theta must be there with a m1 only. Observe carefully. Now already I got it that equation here, and let me write remaining one also. Now here M2G I am taking common. If I take M2G common, M1 plus first M2G is there in both equations. So that's why M1 plus
M1 plus M1.
M1 sine theta, isn't it? Uh, Divided by whole divided by, sorry, whole divided by
M1
M1
plus M.
plus M2 is equal to T. So this equation must be there. This equation will be there for first equation. Once you check whether you will get it or not, you will get for first option or not, as M1 sin theta is there, and in a C option M2 sin theta is there. Once you check, isn't it, Arnav?
Yes, sir.
Then what will be the option? Right option? What will
C.
be the right option? A will be the right option. So this, in this way you have to do. So this is also connected bodies only.
Sir, how
Okay.
will A be the right option?
Now already you know A and C will be right option, no?
Yes, sir.
Right. Among that, once you see first A option here, I will write from this. Now whatever. Okay. From this I am writing here. See, T is equal to M2G common. It is there. And here I am multiplying with this one. Then what happens? M1 plus M2 minus M2. So multiply this minus with minus here plus M1 sin theta by M1 plus M2 will be there. Now see here M2 will be cancelled. Now M1 plus M1 sin theta by M1 plus M2 is there or not? So that only there here or not? Same will be, same is there or not? Right. So Bhumika, what is the answer? A will be the right answer. Have you understood Arnav now? Simplify
Yes.
first. T is equal to M2G common you take, and when you take common that means LCM, and again multiply, and you will get the equation which I got there. Isn't it?
Yes, sir.
Right. Now here figure was not given. Refer to the system as shown in figure. Calculate the acceleration and tension. So same method you have to adopt. Actually figure was not given. I have to find which figure will be there. So after finishing, if any other topic is not there, we will finish it, and okay. So after finishing these two questions, so I will give you diagram for it. I have to refer your ebook, and then I will find out, and I will give you. Now here also some pulley arrangement is there. Pulley arrangement already you discussed in a first case. The pulley arrangement of figure A and B are identical almost all. The mass of the rope is negligible. In figure A, mass M is lifted up by attaching mass 2m to the other end of the rope. In figure B, M is lifted up by pulling the end of the rope with a constant downward force F is equal to 2mg. Calculate the accelerations in the two cases. So you have to calculate the acceleration in two cases. Like maybe you know that now this will be definitely will be equal to whatever your earlier condition is there. This condition will be definitely earlier condition. Which one? First one. Now what is second one? That you have to understand and find out. This first case is there, no? M1 minus M2 by some acceleration equation is there. By using that acceleration equation you have to find. Now Arnav, can you find this answer? Again I have to give hint. Arnav,
Yes, sir.
I have to give hint or you will solve it. Okay, so let me give you hint. Right, this 2m object is there, no? This is first case. So we are solving first case. Now in first case, generally you know that weight of the object will act downward direction. How much weight will act here on the first object? Tell me.
2 mg.
Very good. 2 mg. Why? Because mass of the object is 2m now. So 2 mg will act and tension will act in upward direction or not?
Yes, sir.
Right. Now resultant force will be there downward or upward here. As 2 mg is there. So definitely downward force will be more. Isn't it? Now here mass m is there and here mass 2m is there. So as bigger mass is there to the right side, definitely rope will come down to the right side. That is already given in your problem. So that means for this particular mass, whatever I wrote with some symbols here, now resultant force I can write like this. This is the first case. For first case, first equation I am writing like this: 2mg minus t is equal to resultant force, and that resultant force will be equal to 2ma, isn't it? Acceleration of that object will be a, and what mass is there for it? 2m is there. So that's why 2ma you can write. So this is equation number 1. Okay,
Yes,
Arnav.
sir. Yes, sir.
Right. Now write it. Equation number 2. This is equation number 1. So that means on the first object. Now on the second object. Now observe carefully. Now here weight will act down, which is mg, and tension now will act in this direction or in this direction. In this direction only now, as it is pulling up. So it will be there in this direction only. So now for second object, T minus mg is equal to ma. Now this is equation number 2. Now add these two equations. Tell me what will be there now. Now 2ma plus ma, that means 3ma is equal to 2mg minus t plus t minus mg. That means minus t plus t will be cancelled. So 3ma is equal to 2mg minus mg, that is mg. Now m also will be cancelled. A will be equal to how much here? G by 3. So this is the answer for first case. Acceleration is equal to how much for first case? G by 3. Is it right?
Yes, sir.
How you got it? Have you understood by the equation, Sahas? Have you understood? At least you type me your message. Have you
Sir, he
understood?
left the class as
Huh?
it's 8. Sir, he left the class as it's 8 o'clock.
Okay, okay, right. Now you both are there. Tell me. Now is it right? This particular answer, Mr. Arnav?
Yes, sir.
Right. Equation number 1 and equation number 2. Maybe you understood now.
Yes, sir.
Okay. Now tell me for second case how you will find the acceleration. For second case, how you will find the acceleration. So let us write down first here what is there. Okay. Now here 2 mg force is there now without any object. Object is not there in the second case. Just force is
Yes.
acting. Okay.
Ma equals to 2 mg.
Ma is equal to 2 mg. That's it. Okay. Now let me say on mass m, how many forces are acting?
The two forces.
Two forces. What those two forces are? First one is weight.
Tension and weight.
Okay. Now see, let me draw here. Actually, we can't find. Okay. Now here weight of the object will be there downward, and the T will act in upward direction like this as you are pulling here, isn't it? Now what I can write here, m1g. Okay, as it is moving up, T minus m1g is equal to m1 or m only, no? So T minus mg is equal to ma. Now whether second object is there here? Second object is not there. Now as you are applying the force, that force only will be there as a tension here. So that means T, I can write it as 2 mg. So that means here I have to write like this. T means 2 mg minus mg is equal to ma. Now 2 mg minus mg will be equal to mg. So mg is equal to ma. M can be cancelled on both sides. Now a will be equal to g. That means how much acceleration due to gravity is there, that much acceleration will be there in the system, isn't it? Is it clear now?
Yes, sir.
How I wrote T there as a 2 mg? Because no other mass is there. We are applying the force directly. When you are applying the force directly, that force only will act like a tension in that object. So that's why we took T is equal to 2 mg here, isn't it?
Yes, sir.
Is it clear, Bhumika? Bhumika, is it clear? Right, Arnav, maybe it is clear for you.
Yes, sir.
Right. Now find out this answer. In the figure, a man of true mass, capital M, standing on a weighing machine, placed in a cabin. One cabin is there. And the cabin is joined by a string with a body of mass M. The cabin is joined by a string with a body of mass M. Okay. Assuming no friction, negligible mass of a cabin and weighing machine. What you have to find out? You have to find out acceleration and measured mass of a man. As already you know, the two options are there here. Measured mass of a man is there, acceleration is also there. So both you have to calculate. Acceleration you have to calculate, measured mass also you have to calculate. So how you calculate? Think and calculate. I will give you 2 minutes of time, and then you have to say the answer. Okay? Now think and tell me the answer. See, 2 minutes time I am giving to think actually.
So what do we have to calculate here?
You have to calculate acceleration of the system. Now once you observe carefully in the figure, a man of true mass, capital M, standing on a weighing machine. One weighing machine is there inside of a cabin, and on that he stood. One weighing machine is there, on that man stood, and it is there in the cabin, and mass of the cabin is negligible. That is also given. Negligible mass of a cabin is there. Weighing machine mass is also negligible, and he is standing on that in that cabin. And what is happening is, it is that cabin is tied to a string, and that string is again fixed to some mass, and because of that this total system is moving with some acceleration. That means cabin is moving down, that means man is moving down, whereas this particular object which is there on the table is moving like this in the horizontal position. Now what is the acceleration of combined system? That you have to find. So I will give you hint, and based on that hint you calculate. Okay?
Yes, sir.
Right. Now see here. Okay. Right. Now here man is there. Man is traveling down as some weight is acting. So man mass is capital M now here. True mass is mass capital M. So that's why I'm writing mg here. Don't take it as m1g, mg only. So mg is acting downward, whereas at the same time tension will act in upward direction or not? Tension will act in upward direction or not?
Yes, sir.
Right. So here tension will act in upward direction. So now for this particular object, weighing machine mass is negligible and cabin mass is also negligible. That's why I am writing like this. Resultant force is acting downward direction. So then what equation I can write first?
capital M minus T equals to capital MG.
Okay, I'll write here first. F is equal to mg minus t. So this F is equal to capital M into A is equal to mg minus t. So this is equation number 1. Now here, whatever tension is there, that tension only will pull this particular object which is there up of the table. So that's why now what will happen is the tension will act in this direction. So that T, whatever is there, will pull this particular object. So let us consider this mass. It is not given clearly here. It is the mass small m. So now this tension will generally is pulling that particular object. That's why T is equal to ma, small ma I can write. This is equation number 2. Whatever tensional force is there, this tensional force only pulling this particular object. That's why it is moving in this direction. Now that's why I'm writing T is equal to ma. And when I write T is equal to ma, I can substitute this value into this equation. And if I substitute that value into this equation, see here, ma is equal to mg minus small ma. So here I can write like this. If I take a common, capital M plus small m, that means I sent this m a to this side. So I can write like this is equal to mg. Now a is equal to what? I can write capital mg by capital M plus small m. Whether this equation is there for acceleration here in this particular options?
Yes, sir.
Which option?
P.
Acceleration of man is mg by m plus mn. Both are having same option only, no? C and sorry, B and C. Acceleration of man is
Yes,
mg by m plus m. Whether these both will be right now? B and C are right or wrong?
sir, right.
Right, acceleration of man. So acceleration you found, so mg by capital M plus small m. So here B and C actually something to be given in different way, but maybe spelling mistake here, and B and C are right according to writing there. So here B is right and C is also right, as both you got same. Now tell me, measured mass of a man will be small capital M only, or measured mass will change generally? Measured mass of a man. Now generally weighing machine is there, no? Weighing machine will weigh the mass of the man or not?
Yes, sir.
Right. Now on the weighing machine, who is there? Man is there. Man of mass M is there. But maybe you know that whenever any object is there on any surface, suppose here I kept one object on the paper like this. Tell me, on this paper, this pen will apply some force or not?
Sir, but that will be weight, not mass.
Weight will act. This mass will apply some force on this or not? That is only called weight.
Yes, sir.
Right. In turn, this paper also will apply some force on this pen or not?
Yes, sir.
Right. Arnav, you are getting sleep.
No, sir.
Right. So that means some force will act by this paper on the pen or not. See here, action reaction will be there or not. If this is action, pen is acting, some force on the paper is action, reaction will be there or not. Arnav,
Yes, sir, there will be reaction.
reaction. That reaction generally will apply upward or not.
Yes, sir.
Will act in upward direction. So then definitely normal reaction will be there in upward direction. When normal reaction is there in upward direction and you know that object is moving down, definitely what happens is the true mass of the man, whatever is weighed by that particular weighing machine, will not be same to that of his mass. That means how much mass is there? Now maybe you know that when you are moving up or moving down in a, but what we say, escalators will be there. No, escalator or this particular, what we say, lift will be there. No, when you are moving up, moving down with a lift, generally what happens is weight of the man will change because of the relative motion. Now here, whatever the weighing machine is there, weighing machine will not measure actual mass of him, whether it may be less or more actually. That means whatever mass, what mass is there for man actually here. Now observe carefully in the question, what is there? The true mass of the man is how much? M. And whether same mass will be measured by this weighing machine which is there here, same mass will not be measured by the machine, as both the machine and man are moving with some relative velocity. So that's why definitely the measured mass of the man will not be capital M. Instead of capital M, what will be there? Measured mass of a man is capital M into small m divided by capital M plus small m. That means A will be the right option. So A, B, C will be right options and D will be wrong. Why wrong? We will not measure same mass to that of a man which is there generally. So in this way you have to get the answers.